Hello! In this video, we're going to go over the configuration file system, which is how the user makes configuration changes to the Pack Sniffer 2. This allows you to change everything you want. As you can see here, we're displaying our voltage and current real-time, temperatures real-time, state of charge, health real-time, and the high and low cells real-time. As it cycles through, it'll update that. So if you wanted to make changes to what's being displayed, say you don't care about the temperature, you don't care about the actual cells, you just want to see the pack voltage and current, you can go make that change. So I'm going to show you how to actually change that. But first, we're going to go over what all of the config files actually do. So right now, there's 3 of them. And if you go to the website, you can download them. They are located right here. Or download the zip file and you should have them all. But these are the 3 files right now. There'll be more later as more features are added. So as of this video, there's only 3. There's the Wolftronics _ Pack Sniffer 2 configuration. That tells the Pack Sniffer 2 to load these other files and sets up some, the basic stuff about the Pack Sniffer 2. Whereas the Leaf Pack _ A sets up everything for Pack A. In the future, there will be a Pack B as well, so you can run 2 simultaneous battery packs. But right now, Pack A sets up everything for the battery pack that's connected. And then the display, the LCD _ display config file, is what sets up what is shown on the display that it scrolls through. So yeah, we'll go ahead and we'll open up, just do a brief overview of this. I'm going to zoom out here by just moving I've got this on a tripod, so yeah, you have to bear with me. I'm using Notepad++, you can kind of see up there, and it does a really good job with the formatting. So if you open this up in something else, it may be, shifted or might be a little squished due to the way they handle tabs versus spaces and stuff like that. But I think this one does a pretty good job of formatting everything. But yeah, we'll just go over real quick the stuff that's in here. So these are different sections, and then this is a key. So if you remember from Windows 3.11 days or even earlier INI files, the config files are they're just INI files. They follow the same format. So yeah, I have section and a key. So the bootloader section here, the only option is to turn the bootloader on or off. So if you don't want it to do that check at the beginning for the bootloader, you can set that to false. It'll skip it and it'll just jump right to the application. It won't run the bootloader at all. And if you look, I've got the section key, and then I'll have the default value, what your options are for the values, and then what the conversion factor is. That's useful for things down here where they actually mean stuff. And then I have a little description here. So you can always go through and actually read this, but we'll just go over really quick. Next is the Adc Filter Setup. These are all just defaulted to 5. And 5, the real-time interrupt on the Pack Sniffer 2 is at 10 kilohertz. And so the filter values, it's a IIR filter. It's 2 to that value equals a -3 dB point. So you can see up here, I've kind of cheat sheeted that for you here. So 0 would be off. 4 puts a low pass filter at 625 hertz. 5 is at 312.5 hertz. 6 is at 156 hertz. 7 is at 78 hertz. So you can filter it out as needed. So yeah. If it's a very slow changing signal, but it's got some noise on there, you could just crank that up if it's affecting you in some way. For the boost converter, we can enable it if you're powering it externally with 12 volts. You don't need the 5 to 12 volt boost converter. Then you can set this to false to turn it off. Target voltage of the boost converter is, you can see it's 12,000, but if you go look at the 1,000 equals 1 volt. So That's the conversion factor. So it's actually 12 volts. And current limit, you can see the conversion factor is 1000 equals 1 amp. So we have a 2 amp current limit. You can, I think I've limited it. Yeah, so this is the values. It will check you on the values. Like if you try to put in 3000, it'll give you an error saying, hey, it's got to be between 0 and 2000. So there is error checking on all of these values. Soft start, I would just leave it at 50. That's just how quickly it ramps up. If you needed something, if it needs to be faster, you can lower this value. If you can handle a longer curve up, then you can change that to a larger value. But these are all like the general ones. And then the boost converter filter, same as above. It's right now running at 625 hertz loop or bandwidth. So essentially, yeah, I've got a little note here that says, let me scroll that over. That's pretty much telling you that boost converter filter value, lower values make it more reactive to load changes, adds more voltage ripple. Higher values make the converter less reactive to load changes but reduces voltage ripple. So yeah, if you are experiencing a lot of voltage ripple, you can up that to the next value. If you want it to react quicker, like it's dropping out, like some large load turns on and it's dropping out, then you can make that a lower value so it reacts quicker to the output. This next one is the wake sleep key, section. So if we enable it, then it's going to look for whatever input you've set it to. And in this case, we're using ADC1. And then there's a threshold for ADC1, which is set to 500, which if we look at our cheat sheet, 1000 is 100%, so we're looking at 50%. So essentially, if it's above whatever the output is, so if you adjusted it, so assume it's 12 volts, 50%, so it has to be above 6 volts. So if the input on ADC1 is greater, the voltage on ADC1 is greater than 6 volts, it'll turn on the Pack Sniffer 2. If it's less than 6 volts, it'll shut Pack Sniffer 2 down. The alternative is to set this to false, and if you do that, then the Pack Sniffer 2 will just automatically, when powered up, so you can see that right here, it'll just automatically enable and start up when if it's set to false. So if you don't want to use that ADC as an input. Next, we've got the output section. This sets our PWM frequency for all of the out bits, all the sync bits. It runs at 20 kilohertz, and that is for the like the contactors and the pre-chargers. After they've clicked in, it'll PWM them at whatever rate or whatever percentage that you want. I think right now it's default to 50%. That's set up in the battery pack configuration file, which we'll be looking at shortly. That'll be next. Then we've got the LCD display and section, and we set our refresh rate. So earlier I was showing you the real-time updates of the battery voltage and the battery current and everything. Those are set, how quickly the display updates is set by that value. So 200 is 1000 equals 1 second, so every 200 milliseconds it'll update the display. So you can crank that up to make it faster, you can make it slower. It's your preference, kind of like a voltmeter. If you want the last digit to go really quick, you can lower that value. If you want the last digit to actually like be readable, then you can crank that up. I just defaulted it to 200, but yeah, all these ranges are obeyed, so gotta stay within those ranges. The delay, this is the default delay between pages, which is 2 seconds. So you'd see 1000 equals 1 second. So we'll have a 2 second delay between pages. If you set that to 0, it'll just bypass pretty much all the startup, just goes away. Backlight is currently assigned to ADC2. You can see your options are PWM, ADC1, or ADC2. If we're using ADC1 for the input up here, then we want to use ADC2 for the backlight. Doesn't make sense to have it for both, but you could actually set the threshold such that it starts up, and you could actually use the same ADC channel for the backlight. So as you turn the pot up, it kicks on. So yeah, it's up to you. You can make that happen if you want. If you're in PWM mode, this is just a fixed PWM value for brightness. 1000 is 100% brightness. So if you put that at 500, it'll be 50% brightness. The day mode, if you turn this is kind of like how your dimmer knob in your car, when you turn it all the way down, it'll just jump to full brightness as if it's in day mode. So that I have it set to 1% because this is, the 1000 equals 100. So I've got it set to 1%. So if you drop below 1%, then it uses the PWM value for the brightness, essentially your day mode. All that's explained over here in the in here, so you can read that. Next, and this is important, is the it tells the config what file to load, or the config system what file to load for your displays, for all of your pages that you want displayed, your info screens essentially. And that is the file name. So you can create your own custom ones and then change the names and load them whenever you want. So you on a debug one, you name one, LCD_debug or whatever, and it'll give you the debug information. If you just want, your normal running display, you can change it to that. Many options, whatever you want to do. So this will cause it to load that file. And then same with the battery pack. For pack A, we tell it that it's enabled. I guess you could have no packs enabled. It'll go into debug mode if you do that and just show you debug information. But if you have at least one battery pack, right now we only have pack A, and there will be a pack B configuration available shortly once I finish that code. And you can turn that on, and then same as the one over here, it tells which config file has got the information that you need to set up the battery pack. So you could have different types of battery packs. This one happens to be leaf pack A configuration. And then I kind of doing like this is just an IO cheat sheet, so you can, what pin is ADC1 on? Well, it's on pin 5 of the 14-pin connector. What pin is ADC2? That kind of thing. So when you're choosing that, you can highlight it and it'll show you what pins will use that, which is useful. But essentially, I kind of standardize like the pack here. This leaf pack A is using the 14-pin connector, and then we would use for leaf pack B, we would use the other connector here, the 10-pin connector. So yeah, that's it's a quick rundown of this file, of the main Pack Sniffer 2 configuration file. So go ahead and close that, and we'll open up the leaf pack A. So again, this is the configuration file for the pack A setup. And we've got a few things here. Go over here. So we got the BMS section, and if we enable the BMS, we want to have the BMS enabled. If it's not enabled, then we won't really do much, so it should just leave that enabled. I've got it in there so you can turn it off if you want to do. Our output here is source 1, and there's a little cheat sheet here that says it's pin 3. That will turn on, that's the power, that supplies the power out to the BMS. It's a source driver, so that will turn on power, and your options are source 1, 2, or 3. There's only 3 pins on the Pack Sniffer 2 that source current. All the other ones sync current. And then we tell it which bus we want. We want to use CAN bus 1. CAN bus 1 is permanently attached to the 14-pin connector, and CAN bus 2 is permanently attached to the 10-pin connector, 5x2. So yeah, that's why I think we'll just do like pack A is always on CAN 1, but you have the option to change it if you wanted to. Hardware is using Leaf hardware. Protocol is the Leaf CAN protocol. And our scan delay is, I've got it defaulting to 1 second here, because 1,000 equals 1 second. And this is the delay between the full BMS scans when it goes out and reads all of the cells in the BMS, in the Leaf BMS. So every second it'll ask for all of the cells. However, keep in mind that the Leaf BMS itself takes 680 milliseconds to complete its internal scan, because it has to go and serially shift all 96 voltages over. So don't go faster than 680 milliseconds, otherwise you'll get old data every time. So keep that in mind. I didn't limit you. You can crank it super low if you wanted to, but it'll just give you stale data all the time. Yeah. So next is the power control setup here. And so we've got the pre-charger. If you didn't need a pre-charger, you could set that to false. This assumes that you need a pre-charger. I highly recommend it. Our output is set to sync 1. So again, you can use the cheat sheet to know which pin it is if you're wiring it. All of the ones that are in here are the default wiring that's shown on the schematics that are on the website. These schematics here use those, the default values. So that's what it's referring to. So we've got the pre-charge delay. This is set to 2 seconds, so it'll pre-charge for 2 seconds. And then the econo delay, it's not really useful for the pre-charger, but it's in there anyway. But after 200 milliseconds, we then PWM it at 50%, because 1,000 equals 100%. So what that means is it kicks in the pre-charge relay with full 12 volts. Then it PWMs it at 50% duty cycle at that 20 kilohertz we saw earlier. And that holds it in, because it doesn't take as much energy to hold it in as it does to kick it in. And then it'll do that. So it pulls it in for full 12 volts for 200 milliseconds, and then goes to 50% duty cycle to hold it in. So it ends up averaging to like 6 volts to hold it in. And it's the same for the negative and positive contactor. So you can see you can enable it. If you didn't have a negative contactor, you'd set that to false, and it will just pre-charge. It just assumes that that's always closed. It'll pre-charge and then turn on the positive contactor when it's done. Turns this guy off. So same over here. For both of these, you can set it to be enabled, and then which output you're using. You can choose 1 through 7. Oops, can't see that. You can choose 1 through 7 as your sync outputs are valid for that. And yeah, so you end up doing same thing. We've got the economizer delay, 200 milliseconds, and you can go in there and change it to whatever you want, and then it'll hold them in at 50% duty cycle to maintain it. So you can lower that if your voltage is really high. You can lower it, or if yeah, it's just whatever whatever, you know. These are all default values. They all work, so probably don't actually need to change it. Now this is a section you're probably going to change. This is the voltage monitor section. So we've got essentially 4 modes here. We have the overvolt. This is automatically, if you go over this voltage, which is set right here at 403.2 volts, because it's 1,000 equals 100 volts. So if we go over 403.2 volts, the contactors will open and shut down. This is an overvolt condition. We're going to shut down. Same with undervolt. If you go below 307.2 volts, it'll shut down the battery pack. This is just our protection system. You optionally can enable any of the outputs that you want to also turn on in that event. So that gives you the option here as well. So these are just examples. They're turned off for now. Then we've got our full volt and low volt. So these are the ones you're going to be using the most. So you're going to be charging, and then once it gets above 393.6 volts, we're going to trip that, hey, the battery pack is full. I have this enabled, so it's going to turn on sync number 4, and that might be what tells your battery charger to shut down because you're completely full. Same with low voltage. I have it enabled. I'm using source 2. These are just random. I put in here. I think these are the ones that are on the schematic that I've highlighted as recommended. That would be used to, say, shut down your, or tell, if your battery is getting low, you can go into limp home mode. That's useful. There's this invert here, so if that output needed to be on when you're not in the low voltage condition, or if the output needed to be on when you're not in the full voltage condition, you can flip that invert to true, and it'll maintain that. And then also, we have cell. So you can see the conversion factor there is 1,000 for every 1 volt. So if we're at 4.2 volts, we're going to be overvolt. If we're at 4.1 volts, we're considered full. 3.6 volts is a low voltage condition, and anything below 3.2 volts will shut down the battery pack. So I think these are the ones you're going to be changing the most. And then current monitor, same deal. We have, so 1,000 equals 100 amps. So we have 250 amps positive and negative 250 amps, which is what the Nissan Leaf battery packs can do. So if you go over that, it will shut down. And then again, you can turn on one of the outputs as a warning. Same with over temperature. You can set, I've got them set too. So 100 equals 10 degrees Celsius. So this is, if we get over 55 C, we're going to shut down. If we get below negative 20 C, we're going to shut down. And then the low temperature warning comes on at negative 5 C, and high temperature warning comes on at 40 C. So again, you can go in here and change these to whatever you want. And then you got the little cheat sheet at the end. So go ahead and close that. Oops, I killed it. So next we want to look at the displays. So this is where you would set up what you want it to do, what you want it to show. So at the beginning it shows a splash screen. You can go change it to whatever you want. It doesn't have to say Ultronics Pack Controller version 1. That'll be the default. As new versions come out, I'll increment the thing there. If you want, you can make it say, Jim's Super Truck, whatever. Doesn't matter. You can set it to whatever you want. These are the currently enabled ones. So we've got, we can display our pack voltage and current. You can see it's kind of got like a little representation of what that's going to look like. The descriptions are going to show the voltage and current if it's enabled, and then the delay. The enabled equals true means it's going to show it, and then the delay being 5,000 means it's going to run it for 5 seconds. It's going to display it for 5 seconds. We've got a pack temp. We've got the state of charge health. We got the high and low cells. We got our cell average span, and we've got one that will show all of the cells in order. So yeah, those are all pretty self-explanatory. If we wanted to, so right now we were showing, if we don't want, since we are editing config file, we can come in here and say, okay, we don't want to show the pack temperatures. We want to see just the voltage. So we can set this to, being that I'm away from my keyboard, we'll just cut and paste. So we're going to set that one to false, pack temp to false. We don't care about that. Yeah, we don't really care about the state of charge either. So we'll change that to false. And we do care about the high and low cell, but we also want to see, you know what, we don't care about that one. We'll just get rid of that, but we want to see our average cell span. So we'll set this one to true. And we don't really want to see all the cells. So yeah, so now we're just going to display our pack voltage in amps for 5 seconds, and then we're going to show the cell average span between the two. So yeah, I don't know how useful that would be, but that's what we're going to do. So we're going to save that, and we'll close this, and we'll go ahead and eject my SD card. And same thing, we'll just go ahead and yoink that out and put it into the Pack Sniffer 2 here, which has been running. You can see, if you remember before, it was what it was showing, but we got the temperature and stuff like that, so we'll just set that in there. And we'll go ahead and power cycle it. So turn it off, turn it back on. And there is kind of a bug there. It should be, the backlight doesn't turn on in the bootloader, so I need to go investigate what's going on with that. I think it's because I've set it to the ADC, and I don't think the bootloader supports that. But, yeah. Oh, and we're also running, I think I had a newer version of Flash. Anyways, we'll just do a quick little thing here. So he's changed our config settings, and now we're going to launch our program. Our ignition is on. I'll show you that here in a second. Found our battery pack. We're going to pre-charge it. Enabled. And we're showing our voltage. I think it was for 5 seconds. And then there's our average voltage and our span, and then it goes back. So we were successfully able to change our display to what we want. And I should pull that back up. Hold on. Except I pulled out the SD card, so yeah, hold on. Yeah. Here we go. Okay, so our voltage, our warnings, let's see. So our full, let's say our low voltage is set at 346.6 volts. Do you see that? It's right there. 345, yeah, 345.6. So we're going to turn the voltage down. I'm going to turn the pot here, which is my voltage on my battery pack simulator. So we're going to turn that down, and then get this in the. So remember I had those outputs hooked up. So once we get below that value, what did I say? It was 345. Yeah. Okay. So let me keep going. See, we got our output flipped. And battery pack A, low warning. And the cell is also low because the simulator just takes the output voltage and divides it by 96 to get the cell. So we've got a warning here that we're low voltage. So it'll cycle through, it adds the warnings there. So if I were to turn that back up, if I remember which way to go, otherwise we'll kick it out. So we start turning it back up. Our warning went away, and it won't show. Well, it did show that we have cell warning, but once it updates, normally your voltage isn't changing this quick, but when it did the scan, it still had an old value in there. But now we're good. So if we turn it the other way, we're going to go high voltage. So what is the full voltage is 393.6 volts. So if we go crank that up, so we got a battery pack warning. Our battery pack is full, and you can see my other output changed because I had set that up to be sync 4, whereas the other one was source 2. So those are the red and green LEDs on my little box here. So we can go ahead and turn that down. Oh, I kicked it out. I went the wrong way. Yeah, I was worried about that. So I went too high. So I kicked it out, which is okay. We can lower the voltage to somewhere reasonable. And now that it's disabled, due to an overvolt, it'll stay in that state. But we can actually flip our ignition off. I have it hooked up to a pot. You'd probably actually use a switch, and then flip it back on, and it'll reset the condition. So it'll, since I've changed my, I moved my pot back into a region where we're good. Now we're back up and running. So yeah, the other pot is the dimming because I signed it to the other ADC channel, so I can lower the voltage here, and that was the day mode. So it's really dim, gets brighter. I think that shows up. So now it's super bright, dim, and then if you go all the way to 0, it goes to full brightness. I don't know. I did it that way because that's what my truck does. If you turn the dimming knob all the way down, then it goes to full bright. So it's did the same way. You can always go and change that to 0 if you don't want to do it that way. 0. So I was going to show the overcurrent, so I can adjust the current here. I'll go, so I gotta wait for it to come back. Okay, oh no! I think it was 250 amps. Oh, we kicked out. Pack A disabled overcurrent. So if I turn the current, if I leave it in that condition, like I don't change it, if I shut it off and then turn it back on, I'll just immediately say, hey, I can't turn on because it's overcurrent event is in progress, and it'll show you. So I'll go ahead and shut this off and turn down our current, and then we can start it back up. Actually turn that back down to around 0. Anyways, yeah, that's how it works. Pack Sniffer 2 configuration files let you change stuff. Anyways, really long video. Thanks for watching. Bye.